Thank you. So just checking the volume is okay. I guess it is. It's over there. It's fine. So apologies for the delayed start. A little bit of an old laptop, but so long as we've got internet, which we do, I'll be able to do the technical demonstrations a little bit later on. But in the meantime, I can go on and plow on through with the slides. So as you can see, we're currently in the graveyard shift of the day. So I'm going to try and not use the full 45 minutes and try and keep it sort of fairly high level, but at least give you an idea of what I use Microsoft SQL Server and R for, SQL Server 2016 specifically, and how these tools can be used together for something like data science, a very broad area like data science. There's also a little bit of an update to this presentation where I'm going to talk about Python, because recently there is a development in the Microsoft world where Python has now been incorporated into SQL Server 2017, which means that you'll be able to use R, Python, and SQL code within the same scripts. So I'll give you an overview as to just what that looks like and how you might be able to use it. Just a big thank you to everybody who gave me the chance to speak today, to all the sponsors who obviously made this event possible. I've been a speaker at Data Science Fest before, and they're a really, really great project, and I hope that they can continue to do more and more things like this. So again, thank you. So today's session, I'm going to go over what it means to have R and SQL Server in the same stack. So just a quick poll of the room. How many people use R on a daily basis? So, okay, cool. What about Python as well, just on the off chance? So is Python probably your go-to option for machine learning and stuff like that? Yeah, that's fair. So I'm going to talk about what it means to have R and SQL in the same BI stack, so when I'm using SQL Server at the same time. If you don't use R, I'm going to try and convince you some reasons why you might want to use R or learn a little bit more about it, especially if you're dealing with relational databases on a daily basis, and give you a little bit of an update about Python. I'll have some technical demonstrations lined up, so I'll give you an overview as to what this looks like, so how you might set up something like R in a relational database, what executing a script looks like, and it's more straightforward than you'd think, which is quite nice. And then I'm going to actually talk about a specific product of Microsoft's. I'm not in any way affiliated with Microsoft. I belong to a company called Consolidate, and we use a lot of Microsoft products. So I'm always very keen to give you a sort of no-nonsense, real-world view as to some of these products, because it's all well and good when they release a brand new product where it's not exactly sort of clear where you might use it. So I'm always happy to give a critical evaluation of some of these, but these are just the tools I use on a daily basis, and so they're the tools that I happily talk about. So there are some specific R libraries I'll show you, what they're going to be used for, how you might explore and summarize data with them, and finally how you use the sort of the business ends, the predictive modeling, and how you scale for big data. Quick one about me. As we already heard, I'm a cognitive neuroscience graduate, so I try and take experience from having a sort of basic statistics background and building on it, and how psychology and behavior comes into designing an algorithm for a front page, for example, a recommendation engine, etc. I feel that it's really, really closely connected, and that it's a really potentially interesting area of business in the future. So my main tools are SQL Server 2012 onwards, so probably more 2014 and 16 if I had to pick one or two. I've since then moved on to the Microsoft R products and learnt a lot more about open source languages like R and Python, so I use those a lot in my daily workload now. I also use a lot of these big data technologies, so if I had to pick one that I use more often than not, it would be Cassandra, but I do have to use Hadoop and Spark on a daily basis as well. I do ask that you invite me to connect on LinkedIn, because that's where if you have any questions about today or about any of these tools, then I'm easy to connect with on LinkedIn. So long as I've maybe had a brief conversation with you before, then that's absolutely fine. If you have Twitter, then my account is probably one of the most boring you'll ever see. I rarely use it. So you may want to try the Consolidator Twitter account, which is all related to big data and data science news and events, and more speaking events in the London area, so there's potentially more interesting stuff on there. So just for some context, I want to compare relational and non-relational, which is not a new topic to any of you at all, but it will give you an idea as to why R is now inside SQL Server. So some of the obvious advantages of relational are that when you store data and model it, it becomes a lot more efficient, so you're not replicating data as much, and data validation becomes something that's a lot easier. You're not having various spellings of first names. It's all, everything has a unique key it can be related to later. And you have this amazing language, this amazing complex language called T-SQL, so for SQL Server. Not complex in the sense that it's difficult to learn, but in the sense that you can do pretty much anything with it. But due to the way that SQL Server is structured, so relational meaning everything has its own row, everything has its own column, doing some operations with data which are especially relevant now, like semi-structured and unstructured data, become a lot harder in SQL. You can obviously store things that are unstructured in a structured database, but in actually analyzing and getting insights from that data is not something you can really do with T-SQL. And so if you wanted to do this before, you had some data like data from, or if you had some images you wanted analyzing or some video, you would have to typically move data around. Or if you wanted to do some normal R analysis outside of SQL Server, you'd have to take the data out, which could be slow, it could be insecure. There's a whole lots of reasons why you generally don't want to move data around. And especially when you've modeled your data and got your reports and decision making, then you've got your data in a good place. But especially now where there's a lot more unstructured and semi-structured data, so semi-structured being JSON, XML, unstructured being images, audio, video, then you've got to at least think about incorporating something else. And being able to do that from the same environment, I think, is the main reason for Microsoft bringing in this tool. Which brings us to R and SQL. So 2016, R was released inside SQL Server. And R has a couple of advantages over SQL in that it's become a language of choice for data scientists for its machine learning libraries. So just as a background concept, a library is a reproducible piece of code that somebody else has built. If you have a specific business problem, chances are somebody's already worked on that before you. So rather than duplicating work, install a package, rerun it, and then get to the point where you want to start doing your particular business need. So that's essentially one of the concepts of R. R also is becoming this really interesting general language. So it was developed a long time ago by statisticians for academia, mostly around 15 years ago. And it's developed from a language called S, I believe, but there's even elements of C and Fortran and some crazy stuff in there as well. But the idea is it was built for statisticians by statisticians, and therefore it has a few weird quirks compared to other languages. So some of the syntax is a bit unfamiliar, some of their naming rules and the way things are set out is a bit strange. If you come from another language from the outside, it may seem a bit strange. But the point is it's now become this language through sheer popularity that people have been adding to, developing, and it's become really popular. And also really flexible and getting more and more robust all the time. So these are a couple of the applications I typically use them for, just very high level. So you can use it for cleansing data. So I take data and I use R scripts if they can be cleaned up in a certain way. Using particular R scripts, I'll typically use those. If I want to analyze a file, so take some basic summaries of a file and then decide based on those analyses how I'm going to proceed to model the data and what I want to do with future data coming in, then I'll happily do that, because one of the key advantages of R is that it's great for dealing with data that can fit into memory. So not relying on, so as long as you've got a machine that can handle it all and do all the analysis in memory, then you're set to go for these sort of ad hoc analyses, which is why it's become a good language of choice for data scientists. And it's one of the main reasons why Microsoft has adopted it. So just some of the main sort of key points of R are some of these. So just to go through them. So open source, meaning that if you are developing a project and so compared to something like paid software, an open source software allows you to see exactly what's going on under the hood, so that you can be sure that you know what your program is doing is in what you intended. It's calculating things correctly. And the idea is as well, people can also peer review your work quite easily and build on it. It's a high-level language, so it's designed that way because it's by statisticians, for statisticians. So the idea is you should be able to learn it very quickly. So actually, 2 years ago, I came from a non-tech background. I came from neuroscience and didn't really have much programming experience. Originally started with SQL and then moved on to R, and actually those two together really helped me to understand how programming languages worked at sort of a logical level. So that's exactly what it's designed for. Short development cycles, so if you are a project manager, you particularly care about how long a project takes, and if a lot of the work has been reproduced already by somebody else somewhere in the world, then that's potentially time saving and resource saving for you. If you have worked in C or Fortran before, then quite a lot of the syntax can transfer quite nicely, so a lot of the loops are the same. You can deal with things with S3 classes, S4 classes. There are some object-oriented programming concepts in there as well. So you should be able to translate very fast. 6,000 libraries are available to you on CRAN. So CRAN is the, if I can remember rightly, the Comprehensive R Archive Network, which is a sort of a repository for all of the libraries developed by people who use R. So if there is a package you want, there's simply a line of code to go and install a package from the internet, and you have that package available locally on your machine or on your server. So you have a choice of 6,000 to choose from. So there's a very good chance that what you are planning to do is already up there in the cloud. And just a couple of extra uses. Data visualization of people who uses ggplots, sort of daily basis, yep. So I think it was originally developed in R, but can now also be used in Python. But the graphics feature of R is quite advanced now, so that's what a lot of academics use it for. The maths engine in the background is quite, I've been told it's quite good. I think you probably know more about that than me, but I've been told that doing the complicated maths is R does it quite well. And there's obviously machine learning libraries which have become very popular, especially if you're using Kaggle. So if you are competitors on Kaggle, you'll quite often see that scripts are written in R, Python, for those reasons. So what you'll see is if you read into Microsoft R a little bit more, is that they have a product offering. One in particular product, actually, who's heard of Revolution R? Yeah, cool. So just as some context, Revolution R was developed by, I think, Revolution R, and it built on open source R by applying multi-threading to some of the maths libraries. So for working out the linear algebra, for example, some of the linear algebra functions. There's maths libraries in there, which one of the disadvantages of R is that it's single-threaded. So you are kind of hindered by performance and also by memory as well. It has to fit in memory. So Revolution R actually came in and developed a new kernel which can handle multi-threading for some of the math sides of things a lot more effectively. What this essentially means is that quite a lot of scripts run in R, when transferred over to Microsoft R, actually run a lot faster, or reasonably faster. So I've actually taken it to minds to always use Microsoft R, because it's a complete product in itself. You can use all of the same scripts and all of the same libraries that you can in normal R inside Microsoft R. I think it's maybe one release behind, but they're constantly keeping up. So it generally makes sense for me, especially if you've got good hardware, to use the Microsoft R version instead. And they've also released a couple of extra products on top, which I will show you in a couple of the demonstrations. R Open is when Microsoft acquired this project and turned it into Microsoft R Open. They renamed it. They've since then built on top a product called R Client, which has a couple of extra functions in there for data science and for scalability. So the idea is you'll be able to run a lot of the same linear models or random forests that you would do in R, but do it in scale. So over multiple cores, over multiple machines with multi-threading. So the idea is unlimited scalability. I say quote unlimited scalability, but that's essentially the idea. If you want to go and try this yourself, you can go and download our client, which contains all of the proprietary functions. You're only limited by the number of cores you can use, which is 2, and it has to all fit in memory, but you'll be able to try out some of these functions yourself. And our server is what they've built on top. What you see inside SQL Server is their proprietary thing. So the idea is you should have unlimited scalabilities. You can choose as many clusters that you want to build as you want. How many people regularly working with SQL Server in the room? I think that's probably the most hands up so far. That's cool. So this was released, I've repeated this, so in SQL Server 2016 onwards, this R component will be, and alongside SQL Server, you've got JSON supports, the integration of R, temporal tables. I think that slide's probably for another time, but I think the takeaway point is just the code on the right-hand side. So just as an explanation as to what goes on inside, and you'll see this in the technical demonstrations, this is essentially how you call R inside SQL Server. You declare a variable, a nvarchar, you set a value, and that value is your R script, and then you simply use a brand new system stored procedure called sp execute external scripts, which will run whatever is in that text variable, along with any extra inputs that you decide to give to it. And we'll go over a few of those in a bit more detail in a moment. Yep, so just as a quick one as well, very recently in the last couple of weeks, they've announced that now Python is available in SQL Server 2017, meaning that you can run Python scripts and R in the same stored procedure. Has to be in a stored procedure, by the way, can't be done in views, but we'll see how that pans out. So the main advantages of this is that you're not moving data around from Python to SQL Server and back, so it's a bit more secure. You have all of the 90 file, pretty much, I think it's almost fully compatible. Most of the libraries will work, if not all of them. I'm not 100% sure, so don't quote me on that yet. But the majority of the libraries are available to you. So anything that you've been doing in sort of AI, VR, any sort of, even like a chatbot application, whatever you've been working on in Python will translate over quite nicely. So this is a nice new window for application developers. It's nice for database administrators as well, just general development. It's a nice touch. Like, I don't know much more about the Python aspect of it yet. I don't know if it's more than just a toy at this point in time, but happily write blogs about them when I know more. So this slide is just to go over a few more of the reasons how I might use something like R, and therefore how you might use something like Python inside SQL Server. So just as some background, I'm currently a data engineer at a company called Consolidate. We have 15 people working for us and a couple of quite high-profile clients on our platform, including a high-profile retailer and a coffee producer. But these are some of the applications where we've used R inside our data platform. So for our own social media activities, we monitor. There's a REST API. So we go and collect our interactions from LinkedIn, and we do some internal analysis on how much a connection is worth, how much a particular like on a tweet is, and we can estimate things like our reach for a particular post. Same with Twitter. So we can model our social networks inside R first, or do it inside SQL Server or a graph database, and then we can query that. We can also go and collect that data initially from REST API, same way as LinkedIn. Hadoop is a connector from R to Hadoop, and therefore there's now a connector from SQL Server to Hadoop as well. So if you have a Hadoop cluster somewhere else in your network and you want to be able to pull files from or push files to, run a job of any sort, a MapReduce job, then you can do that from your SQL Server console. Excel, so this is more for data cleansing. So taking dirty Excel files, running rules over them, cleaning the data, pulling it out, and then standardizing the files before they go into SQL Server is something we've done. Neo4j, we've built connectors into Neo4j so that we can query it nicely. Running Spark jobs, we've done. Connecting to Power BI, so another one of my demonstrations is something where I build an R application. It streams data live in real time. So around the inauguration, that was a really, really sweet thing to do because we were actually analyzing people's sentiments on the way in. So imagine receiving 20, I think it was something like thousands of tweets a minute, thousands of tweets. It was close to something like 8. And then all of those insights being streamed via Azure straight into Power BI, where you can actually analyze the hashtags and the sentiments as they come in. It's a really, really nice demo. But again, something for use of R. Azure machine learning, I think there was a question in the last talk about using sort of machine learning as a service. It's not something that we've used massively, but it's something that's on our platform. But Azure ML has Python and R support. So you can build these data pipelines using Azure ML and R. Obviously, it's in SQL now. There's SPSS. I don't know if you can see that on the bottom. It's not that clear. But analyzing SPSS files is something that we've regularly had to do for a market research client of ours. So their problem was that they have a fully licensed SPSS bit of software, but we don't. But there's actually open source equivalents to go and read that data and pull the metadata out. So if you want to model that in a database, in a data warehouse, then knowing exactly what value is assigned to what question label and knowing how questions and answers are laid out is something that we've done in SQL and used R to get that data out initially. I don't know why you'd want to do this, but somebody asked us once to call R from Python and therefore call Python from R. I mean, I think just to see if they could do it, but it can be done. And integration into Azure. So I think it's being picked up by Azure more and more, but in particular, we use R to go and get files from a data lake, just to pull files from and push them to, just as a sort of early stage in the data pipeline. And if we go through this slide, I think that should give you an idea of how we use that. So yeah, flat files using R, sometimes pulled from a server into some sort of Azure storage or a SQL database or even a Hadoop cluster, can be used using R or Python. Visualization can be done, reporting can be done in R or Python. And any sort of machine learning underneath, feeding the results back and visualizing those results, all can be done in R and Python. So the idea is it's a really flexible language which sits at any point in the data pipeline. It's a fast language, it's not that slow, and it's being built upon all the time, so the algorithms in the background are being improved by some very savvy people in the community. And it's going to become a really good language where you just write what you want, and you don't necessarily have to write brilliant, optimal code. You just write what makes sense to you, what's readable, and then people working on the code in the background will make that faster for you. So these are just a couple of the advantages of learning a language like R and knowing how to incorporate it into SQL Server. I think I'll skip this because this was a leftover slide, but as we've said before, you can use R and Python from Azure ML if you really want to. Shame about the link colors, but if you want to go away and learn some R, there are a couple of good sources. My particular favorite, Stack Overflow, obviously. They have some amazing wiki pages which are really well developed now, so just go and have a look at those. Consolidate has some good blogs. If you fancy a challenge and learning R inside R, then there's a package called Swirl, and you can do it all inside the console. It's really nice. So if you are willing to learn some language at this point, some R language, then I'd suggest you go and do that. And with that, I would like to try and show you some demos, and hopefully what I'd like to show you is some analysis. We can do some analysis right now of potentially the tweets coming in about Data Science Fest. So if you bear with me while I try and connect to this machine, because I was having some issues earlier. Has anybody got any questions initially, just so we can we're not sitting in silence? Yes, sir.
You mentioned 6,000 libraries for R.
Yes.
They're not consistent, and there's an awful lot of overlap. So how do you choose? How do you choose and assess which are reliable and worth?
That's a good question.
Working with?
So the R. I think there's something called the R consortium. So before a package even makes it to the network, it's peer reviewed and checked. So you can be sure that all of the languages that are actually up there on CRAN are at least fairly reliable, if not more reliable than most. If you're installing somebody else's package that they've developed via something like GitHub, if you just download someone's package from a GitHub repository, it's obviously a bit riskier, but I think there's generally a consensus that downloading from CRAN is quite safe.
No question.
Sorry, yes.
So, no question. Hi, thanks for the introduction of this product. I have a question about R and Python. So both R and Python, they have some they have some third-party quite good IDE development, such as RStudio or PyCharm, which been using by loads of developers or data science to get the best productivity. So in terms of if the code or program developed by under this native IDE, is it very easy to integrate into the SQL product, or?
So sorry, repeats the sort of the last.
Yeah,
You mentioned an IDE.
yeah, because is the code or the program developing by this native IDE such as RStudio or PyCharm, are they very easy to integrate it
Yes.
back to the SQLs, or?
So actually, these products are designed so that you don't have to change IDE. So if you're working in an R IDE, you can call SQL Server functions and they run in the context of SQL Server. So you don't ever have to leave your IDE. And the same will be with Python. So you work entirely out of your Python IDE. You can call SQL functions and then use the embedded Python scripts inside that SQL, but it runs in the SQL context. So the idea is you won't ever have to leave your IDE. That's how it's intended to be built at the moment.
Right. If in this case, I assume that the SQL product will have the compile or integrated either from Python or R. Are those core compile will be updated when the such as the R, they get a new version, or Python they get a new version, or they will stay with the SQL servers? Will be behind the.
I'm not sure about how the updating is generally handled for Python or even for R. Sorry, I'll maybe come to me at the end because we're sort of
Right.
I think we're running out of time as well. But I just want to show you some things. Right, so we should be ready to go. I'd like to show you just a couple of examples on how this works. So what I have here, we'll redo that. So I have just a couple of code examples as to how you might set something like this up. And I'll go through these fairly quickly. If you want to have a go with these code snippets, if you want to have a go with this yourself, then you can go to my GitHub, which I'll try and link to. Is there a forum? Well, I'll find somewhere to leave my GitHub, but all of the slides, all of the code will be available on there if you want to go and try this yourself. So just to go through a couple of these examples, so just as a proof, we are using SQL Server 2016. You can use the developer edition yourself. You can go and download it and use it for free. You don't need a license. If you're on Azure, if you work with Azure regularly, you can actually build a VM with everything ready for you, which is what I've done. But if you're setting up your own server, you generally have to know about this, which is your executes. You have to basically tell SQL Server to be ready for external scripts to configure them. It's not always an out-of-the-box solution, so there's some minimal preparation required. But this is essentially how it works, like we showed you earlier. So we declare our R script, we set it to the value that we want. So all of this is going to do is going to take the internal data set called iris, the flower data, the classic flower data, and run a function over each group, produce the median. And what we have here is actually a few inputs. So first of all, tell it what language. Currently there's only one, but in 2017 there will be two. You tell it what the script should be, and also tell it what the output variable name should be. So I've simply written some code to produce a variable called df, and I'd like to spit that out at the end. So what we should see is just a very simple median of all of the data. So that's just proof that that's what's happening. Any DBAs in the room, or anybody who cares about performance and wants to restrict how people use this tool? There is a special, you can create a resource pool for R. So I have to control the amount of CPU available in memory. Because R's all done in memory, you have to be quite careful. Obviously, SQL Server querying is very highly memory intensive anyway. So having another highly memory intensive thing in there is going to be potentially quite risky if you don't necessarily know what you're doing. Anyway, let's do some more interesting things. So I've developed a function, and it's called store procedure search Twitter, which, if I bring this up, I'll show you just very briefly what's going on. We have the same again, declare the R scripts, and what looks like a very standard R script, including, can everybody see, by the way? Would you like it a bit larger? Oh, are we okay? We're okay. All right, so I've installed some libraries of my own. This twitr is a library specifically for getting data from Twitter, so I don't have to worry about doing the complicated stuff of authenticating. It does it for me. I have a couple of others that I want to use, and I've dynamically made this script so that the user picks the search term. And I'm obviously going to use Data Science Fest, because what else would we use today? There's an option to get my keys from a local file, so it works absolutely fine reading files from the system. And then I continue on with my script as I get further down. I take the data, I convert it. It comes in as JSON, so I convert the JSON into a table, and then I select what I want from that table. The fun part is, which I'll try and show you at the end because we're running out of time, when I select a number 1, my Twitter account will tweet the result of this stored proc. So we should hopefully be able to see what happens here. So let's go and let's make this quicker. Let's get 250 tweets about Data Science Fest and see what happens. Should take around 4 seconds, 4 or 5 seconds. Hey, there's me. So we know this is kind of true, and I'm not just making it up. So we have some tweets here, and we have a timestamp to pretty much prove it. So this data has been pulled in the last 5 minutes, and that's actually R going to get that data and then SQL Server processing it. So that's kind of cool. It's still a little bit of a toy right now. So what can we do with this data which maybe R or SQL Server can't do? So R's good for regular expressions, as is Python. So I want to use some regular expressions and find out what the most common hashtags are for any number of tweets from today. So just very, very quickly, just go through. We've got the same kind of concept here. So we're going to declare some tables, including declaring our script. These lines here will pull out the hashtags. And then as I get further down, I create a table to insert them in, this tweet table up here. And actually, just to demonstrate, this input data, you can give it a SQL query. So imagine I've got 1 million rows of training data in a SQL database somewhere. I can actually stream the contents of that table through an R component and choose how many rows to do it at a time, just to control for memory. So I could stream in 250,000 rows at a time, train a model, and then produce a model at the very end, and predict results from it using that model. So that's just essentially what we're doing here. So let's just go through and very quickly see what the top hashtags are for the day. Should be quite fun. Does anyone get any predictions? Aside from Data Science Fest, what the top one might be? Fun. Tired. Yeah, be nice. Apparently it's data science. Who knew? This actually has a vaguely useful application in that we use this sometimes to pick what hashtags we want to use in certain tweets. So we don't use the most common one. We use things that are vaguely connected but target a different audience of people. So that's essentially how it works in R. I'm running out of time. I have 2 minutes, but I just want to show you what the functions look like, the proprietary functions, and how they might differ. I don't have an example here, but if you come to me afterwards, I can give you some ideas. We have some import functions, which look something like this, rx import. So this mushrooms data has 8,000 rows, but if I move that up to 1 million, I've seen it import 1 million in under a second quite easily, even more than that. So the limit I've seen it go to so far is around 150 million, sort of streamed in a couple of seconds, 2 to 3 seconds. It's quite nice. You have different functions for reading in different types of files already built into this library as well. So we can read in SPSS files or text files. We can convert files from one format to another. So we have a particular file in this variable. I want to create something called an XDF. This is the common use for it. So one of the main features of this new R server is that data frames can be stored on disk. So if you have a large file, you'll convert it into an external data frame and then do all of your analyses from the data frame that's stored on the disk. That's the workaround that Microsoft's come up with in order to do these big end applications. Knowing that I'm running out of time, if you have metadata inside your SPSS file, then it picks that up automatically when you create these external data frames, so you can go and retrieve that. It's just stored in there. We can summarize data quite nicely, so I wonder if this works. It does. So that took 0.001 seconds because it was very small. But it will give you a profile of what the data looks like, so the number of observations that might be missing, means, standard deviations. And the fun thing is, it will also do some aggregations for you and counts. So anything that can be categorized can have a count produced immediately. And the highest extent I've seen this for is a couple of million being produced in under 2 seconds again, but having countries and names, first names, cities, all summarized for me. So immediately I know where to go, which kinds of analyses I want to do first. You've got your general linear models, and you're able to predict when you build these models. It's very, very similar to R and in a sense Python. I know I'm running out of time, so if anybody has some questions about these specific functions, then come up to me afterwards. You can even visualize decision trees like that, which is quite nice. You can drill down into where the decisions are being made. So this is some mushroom data that I've produced earlier, where I'm predicting whether something is poisonous or not. And so you can actually run random forests and create decision trees from this data and produce it quite nicely. So there is a lot of functionality, and I probably can't tell you all about it here, especially now that I've got -3 minutes. So, but thank you all for listening. And yeah, come and ask me any questions if you have anything you want to ask. But again, thanks for listening.
Great.